Good morning. Those who are joining, come on, just write your name once so that I can recognize you. Just write your name once. I can see Jasraj, Abhay Gupta, Subhama, then Sneha. Come on, those who are joining, just write your name once so that I can see you. I can recognize you. Nitik, Suparna, Isneha, Amisha. Okay, fast, so that we can start our class early. Come on, fast, start fast so that we can start our class early. First, all the students are not attended yet. They have not joined yet. I can see Kesang, Tapabrata, Rohit, Isneha, Namrata, Pratham, Avinay, Maitri, Subhendu, Priyansh, Sahil, Amisha. Come on, fast. First, join first. Join first, all of you. First. Are Nilesh, you are not getting notification. Why so? All other students gets notification. Like other student of class 10, do you get notification? Nilesh Dev, this was he daily he says that he is not getting notification. I don't know why. Other students are getting notification. Pratham is saying China company mobile he is using. Okay, see, others are writing yes sir, yes. They are getting notification. I don't know why. Pratham is saying that you are not getting, Nilesh is not getting notification because he is using a China mobile. That's why. Acha, Sahil is saying sometime late, but we get. Okay, you get the notification. Alchemy, let's join. Come on, join first, all of you. All of you join first so that we can start. Today we'll have a quick revision on this chapter, electromagnetism. All the question and answer will prepare now. Okay, in this period only, we'll prepare all the question and answer. Though one more topic is left from this chapter, but that topic will do it in our next live session. Okay, in our next live session we'll do the rest of the portion. Is portion is left which is important, that we'll do in our next live session. And today we'll do all the question and answer of this chapter, electromagnetism. Okay, fine. So all of you get ready with your physics notebook. Okay, keep a copy with you. I will tell you the question, some answers also, and you just match whether you have prepared those things or not. These are important for your board exam. Fine. So get ready with your copy. Fine. First, Okay. Uh, Okay, so I hope you all are ready with your physics copy. And today, as I told you, that today we will do all the question and answers from these chapters. The answers you can only write; it's not a problem. You can write the question. Sorry, you can write the answers. Question I will tell you, and you just match whether you have finished all those things or not. Okay. So, are you ready, all? Fine. So let's start. Number one, the very first day of this chapter, we discussed about magnetic lines of force. Okay, I will tell you the questions now, and you just write down those questions. And wherever the you will have doubt on the answers, I will write those answers. Okay, I'll give the answers. First question, all of you. The first question: draw the magnetic lines of force. Draw the magnetic lines of force for a bar magnet. Write this question. Draw the magnetic lines of force for a bar magnet. Fine. Question number 2. Write the properties of magnetic lines of force. Fine. And remember, 3 properties are there. Okay, you have to write 3 properties. If you have got any doubt of any of the question after finishing the question, just let me know that this question is your problem. We'll solve it. Okay, so 3 properties you have to write. Number 3, question number 3. Why 2 magnetic lines of force? Why 2 magnetic lines of force? Why 2 magnetic lines of force never intersects? Okay, important question. Why 2 magnetic lines of force never intersects? Fine. Next question. Question number question number you put according to you. Okay, I'm just saying you the questions. Next question you write. A magnetic needle is placed. A magnetic needle is placed just below an insulated wire. Just below an insulated wire. Describe the deflection. Describe the deflection of the magnet. Describe the deflection of the magnet. Yeah, write it down. Describe the deflection of the magnet on passing electricity. On passing electricity through that wire. through that wire? Same question. Same question you write. Which rule will be applied? Which rule will be applied? Which rule will be applied to find the direction of the to find the direction of the to find the direction of the deflection of the magnet? To find the direction of the deflection of the magnet. Okay. Next question. Write down next question. If any of the question, if you have got doubt in any answer, we can discuss that after writing all the questions. Okay. So next question. Write the properties of the magnetic lines of force. Write the properties of the magnetic lines of force of a straight current carrying conductor. Of a straight current carrying conductor. You remember that one? That straight current carrying conductor. Okay. That magnetic lines of force. Yes, that one. State the properties of magnetic lines of force of a straight current carrying conductor. Same question. Write the same question. Which law is applied here? Which law is applied here? To find the direction of magnetic lines of force. To find the direction of magnetic lines of force. Fine. Next question. All of you write down the next question. State the properties of magnetic lines of force. State the properties of magnetic lines of force formed by a circular current carrying conductor. Circular current carrying conductor. Okay. Did you write this question or you could not write? Just tell me. Could you write this question? Any doubt from these questions? Any doubt from this question? Just answer if you have got any doubt. Good. Fine. You have written fine. So after writing all those questions, we'll discuss your doubts. Okay. Fine. So you have written the question. Good. So next question. All of you, next question. State Fleming's left hand rule. State Fleming's left hand rule. We have already discussed Fleming's left hand rule. You remember that one? Okay. Fleming's left hand rule. State Fleming's left hand rule. Next question. Name the device. Name the device works on this rule. Name the device works on this rule. We know. What is the device? Can you tell me? Which device works on Fleming's left hand rule? Can you tell me? Dolan is late. Okay. Karan Mitra is saying fan, electric fan. Yes. So we'll write electric motor. Okay. Electric motor. Actually, when you are writing electric motor, then you are covering fan and all other devices which works on this principle. So instead of writing electric fan, we'll write electric motor. Okay, all of you. So whenever I'll ask you that which device works on Fleming's left hand rule, you will answer me electric motor. Okay. If you're writing electric fan, that is correct. But if you're writing electric motor, means you are covering all the devices which works on this principle. Understood? Electric motor. Electric motor. Fine. Okay. Next question. All of you, next question. State Fleming's right hand rule. State Fleming's right hand rule. Name the device works on this rule. Name the device works on this rule. Now, all of you, can you tell me what is the device which works on this rule? You have attended all the live session. We have already discussed which device is worked on Fleming's right hand rule. Which is that device? Electric generator. Yes, correct. Electric generator works on this principle. Very good. Correct. Electric generator. Yes. Fine. Electric generator. Yes. Okay. So electric generator works on this principle. Very good. Fine. It's done. Next question. Next question. State the working principle. State the working principle. Working principle of an electric motor. State the working principle of an electric motor. Very important. Done. Next question. State the working principle. State the working principle. State the working principle of an state the working principle of an electric generator. Electric generator. State the working principle of an electric generator. Done. Next, these last two questions, their answer I will tell you those answers. Okay, you don't have to write the answers of this. I will tell you those answers. Now, next question. Next question is, a bar magnet. Next question. A bar magnet is placed on the axis of a coil. On the axis of a coil. Of a coil. As shown in the given figure. As shown in the given figure. I will show you the figure also. As shown in the given figure. Full stop. How the galvanometer will deflect. How the galvanometer will deflect. How the galvanometer will deflect when number A, the bar magnet is number A, A, the bar magnet pushed into the coil. Pushed into the coil. Number B, pulled out from the coil. Pulled out from the coil. Number C, remains same inside the coil. Remains at rest. Remains at rest inside the coil. That much. You have to draw a figure here. I am showing you the drawing. You write it. You know the figure. It's not new for you. We have already discussed. This is the figure. Can you see this figure? Just say yes if you can see this figure. If it is clear to you. If it is clear to you, then just reply me. And draw this figure. This drawing is the part of that question. The question which you have written now. This drawing is the part of that question. And if you can answer this, okay, fine. So draw this diagram. This is the part of that question, and we have already discussed it. Okay, so drawing is done. Now in the same question you write, same question, okay? Same question you write. State reason for your answers. State reasons for your answers. Done? Next. Next question. Right, next question. Two coils A and B. Two coils A and B, capital A and capital B, are placed nearby. Okay, are placed nearby. Full stop. First coil is connected. First coil is connected with a switch and a source. First coil is connected with a switch and a source. Source means electric source. Coil B is connected with a galvanometer. Coil B is connected with a galvanometer. Full stop. Same question, huh? Find the deflection of galvanometer. Find the deflection of galvanometer. Find the deflection of galvanometer on switching on and switching off. On switching on and switching off of OFF, huh? OFF, off. Switching off the current in coil A. Switching on and switching off the current in coil A. Fine. Switching on and switching off the current in coil A. Done. Fine. Same question. What is the reason behind your answer? What is the reason behind your answer? Same question. Same question. Which law is used here? Which law is used here to find the direction of? Which law is used here to find the direction of current? To find the direction of current passing through coil B. Passing through coil B. Can you tell me the answer of this? Which law is used to find the direction of current in coil B? Can you answer this? Write the answer in the comment. Which law is used to find the direction of current in coil B? Yes, yes. Ratul has given answer. Karan Mitra given. Priyansh Kumar. Hey, Priyansh Kumar is wrong. Priyansh Kumar is wrong. Abhay Gupta has given answer. Yes. So what is the law? Lenz's law. Lenz's law. According to Lenz's law, the direction of the current is always opposite to the cause. Opposite to the cause. Okay. Lenz's law. It's not Faraday's law. Priyansh, it's Lenz's law. Okay. Good. Fine. Same question. Same question, don't change the question. Same question. What is the name of the current? What is the name of the current produced in coil B? What is the name of the current produced in coil B? Can you tell me what is the name of that current? What is the name of that current? Can you tell me? Yes, yes, yes. Where is Pratham? Pratham, write the answer. Pratham, write the answer once. What is the current? What is the name of that current? Pratham, write the answer. Pratham is not there. Pratham is not there. Okay. Pratham is not there. He has gone away. Okay. He has gone away. Pratham is not there. Next question. All of you, next question. All of you, next question. Yes, yes. Induced current. All of you, next question. Right. What is a solenoid? What is a solenoid? What is a solenoid? Same question. Mention the factors. Mention the factors on which. Mention the factors on which the strength of a solenoid depends. Mention the factors on which the strength of a solenoid depends. Mention the factors on which the strength of a solenoid depends. Okay. We'll discuss this question. Solenoid we have not discussed before. It's a very easy thing. First of all, we will take a pen. Can you see this pen? I will take this pen and I will take wire, copper wire, simple copper wire. Okay, wire which is not covered with the plastic. The wire which we buy from the market, that is covered with yeah, the wire which we buy from the market, that wire is covered with the plastic, so that we will not get the electric shock from that. Okay, but here we have to take the wire which is not covered by plastic. Okay, just copper wire. Fine. Copper wire. Okay, now what we'll do, we'll take the pen and we'll take that copper wire and I will make round on that copper wire. Okay, I'll make round on that copper wire and then I'll take out the pen. I will get a spring. Okay, I'll get a spring shaped coil. It will look like this. Can you see this spring shaped coil? No, you won't be able to see it. I think here is a spring shaped coil. No, you won't be able to see this spring shaped coil. You won't be able to see here. So that spring shaped coil, okay, if you pass electricity through it, okay, if you pass electricity through this coil, then that coil will behave like a magnet. I will draw it and show it to you. I will draw this. Like I'm making a spring shaped coil, okay, and I'm passing electricity through this coil. Say this one, this figure. Okay, this figure. So see, the battery is connected with it. When I'm passing electricity through this coil, okay, when I'm passing electricity through this coil, then this coil will behave like a bar magnet. Understood? This coil will behave like a bar magnet. Fine. Someone is writing Suman Rathor. Okay. JEE replacement hoga kya? No, it's they are deciding on it. It's not decided yet. It's not decided yet. They are working on it. Okay, they are thinking on it that how the things can be done. They are working. It's not decided yet. The decision is not taken yet. Okay, so what we are discussing. See, this is the coil, and when you are connecting a battery with it, when the current is passing through it, then it will behave like a magnet, strong magnet. Okay, that will behave like a strong magnet. Now the thing is that if you say this, since it's behaved like a bar magnet, okay, and we know that every bar magnet has magnetic lines of force, so it will have a magnetic lines of force. Okay, so for this bar magnet, this is not a bar magnet, but it will behave like a bar magnet. Okay, this will behave like a bar magnet. Now since this is behaving like a bar magnet, we can draw the magnetic lines of force. Okay, but to draw the magnetic lines of force, we have to know which is the north pole and which is the south pole. Okay, which is the north pole and which is the south pole. For that, a very easy technique is there. Okay, which end the current is going, that is south pole. Understood? That solenoid, that coil, which direction? Suman Rathor is writing, very nice teaching skill, sir. Thank you. Thank you. See this. So how to find the south pole? To find the south pole, it's very easy. Which direction current is entering, that is south pole. Okay, which direction current is entering? See, this direction current is entering, so this is south pole. And from this end, current is going out. Obviously, this is north pole. Understood this? So this is south pole. And this is north pole. Try to understand, all of you. So which direction current is entering? This direction current is entering. Okay, this direction current is entering, so this is south pole. Understood? South pole. So now we know north pole and south pole. So since this is north pole and south pole, we know, so we can easily draw the magnetic lines of force like the same way we have drawn the magnetic lines of force for a bar magnet. Same way we'll do here. I'm drawing it, all of you. After that, you can also draw. See, this is the magnetic lines of force. This is the magnetic lines of force for a solenoid. And as we know, magnetic lines of force always moves from north pole to south pole, isn't it? The north pole to south pole it moves. So we can give the arrows here because we know which is north pole and which is south pole. So north pole to south pole, I'm giving the arrow. Okay. See, this way. See, north pole, south pole. Understood? So first of all, what I said that you will take a insulator. Okay, we'll get a spring shaped coil. That spring shaped coil, whichever we'll get, that spring shaped coil. Now if you connect that coil with a battery, okay, with a battery, you will see that your coil will behave like a magnet, a very strong magnet. So, and we call it solenoid. And as I told you that solenoid will behave like a bar magnet. Since it will behave like a bar magnet means it will have some magnetic lines of force. Now to draw the magnetic lines of force, we require to know which is north pole and which is south pole. But it's very easy to find out the south pole. Which direction current is entering? That is south pole. Understood? See, which direction current is entering? This direction current is entering. Okay, so this is south pole and that is north pole. So from south pole to north pole easily we can draw the magnetic lines of force. Fine. Now the thing is that what are the properties, what are the factors on which magnetic lines of force, I mean the strength of a solenoid depends. Strength of the solenoid depends on three things. Try to understand. Strength of the solenoid depends on three things. Number one, number of turns per unit length. Okay, number of turns per unit length. Like if I draw the solenoid again, like this is the solenoid. Just a minute. Number of turns per unit length. See, this is the solenoid which I made. You can see this coil. Sorry. You can see this coil. Okay. Now, say I am making a solenoid. I am making a solenoid where I made turns. Say 10 turns in 1 centimeter. In 1 centimeter, I made 10 turns. But you made a solenoid where you made 15 turns in 1 centimeter. So in your solenoid, number of turns per unit length is more than mine. Okay. In your solenoid, number of turns per unit length is more than my solenoid. So your solenoid will be more powerful. Okay. So number of turns per unit length. Per unit length means 1 centimeter in 1 centimeter or in 1 meter. How many turns you are giving. Okay. So we'll not write only that number of turns. No, we'll write number of turns per unit length. Okay. So if I ask you what are the what are the factors on which the strength of a solenoid depends? Number one, we'll write number of turns per unit length. Number B, say I made a solenoid where I have connected a cell of 3 volt. Okay. What volt I have connected? Yes, 3 volt. But you made a solenoid, same size, but you have connected 6 volt. I have connected 3 volt battery. You have connected 6 volt battery. So obviously your solenoid, through your solenoid, more current will pass because you have increased the potential difference. So more current will pass. So when the amount of current will increase, you will see that the power of the strength of the solenoid will also increase. Understood? Strength of the solenoid will also increase. Understood? So number B is amount of current. Number A was first number is number of turns per unit length. Number 2, strength of current. Now number 3, to increase the strength of a solenoid, you know what we should do? Inside this solenoid, if you insert a iron rod, soft iron rod, okay, so this is a soft iron rod. If you insert this soft iron rod inside the coil, you will see that the strength of the solenoid has increased, just multiplied. Understood? So this is number C. Number C, by using a soft iron rod or soft iron bar, inserting this in the coil, you can increase the strength of a solenoid. Understood? This is the thing. So solenoid we discussed, and so you have written the question also that what is a solenoid and how the factors on which the strength of a solenoid depends. Okay, one more question you write. This is important for your board exam. One more question. Draw the magnetic lines of force. Draw the magnetic lines of force for a solenoid. Okay, draw the magnetic lines of force for a solenoid. Okay. Now, I gave you two questions. What are the working principle of an electric motor? Write the answer of it. What are the properties of, sorry, what is the working principle of electric motor? Write the answer of it. Answer. When a coil is placed in a magnetic field, when a coil is placed in a magnetic field, when a coil is placed in a magnetic field, then on passing electricity through that coil, and then on passing electricity through that coil, then the coil shows a deflection. Then the coil shows a deflection. Okay. Which is the working principle of an electric motor? Which is the working principle of an electric motor? One more question I gave you one more question. What is the working principle of an electric generator? Write that. Write the answer of it. Electric working principle of electric generator. Write the answer of it. Answer. When a coil is placed in a magnetic field, when a coil is placed in a magnetic field, then on movement of the coil, then on movement of the coil, comma, some current gets induced. Then some current gets induced in that coil. Some current gets induced in that coil. Full stop. This is the working principle of an electric generator. Write it down. This is the working principle of an electric generator. Okay. Fine. Now one more question. We have already discussed the answer. One more question. Write down that question. One more question. How will you place your conductor? How will you place your conductor in a magnetic field? How will you place your conductor in a magnetic field? To obtain the maximum force. To obtain the maximum force. We have discussed the answer of this. Can you tell me the answer in the comment section? Let's see. If you have attended all the live sections, we have discussed this answer. Just write in the comment section if you remember. What is the question? How will you place your conductor in a magnetic field to obtain the maximum force? Can you write the answer in the comment section? Let's see how much you remember. Yes, yes, Ratul has given answer. Then this is Champa Pal. I am not able to recognize Champa Pal. Okay, Nilesh also given 90 degrees. Suvendu has written yes, 90 degree. The angle between the conductor and the magnetic field should be 90 degree. Yes, yes. Now Pratham has come. Pratham, in between the classes, I was mentioning your name. I wanted the answer from you, but that time you got missing. Pratham, I was mentioning your name. I wanted you to answer, but you got missing. Okay, fine. So this much we'll keep for today for this class, and in our next live session I will discuss some few important things from this chapter, very important from this chapter, and the portion which we'll discuss in our next class, numericals are also there. Okay, numericals are also there, and in this chapter electromagnetism, only in that portion few numericals are there. Otherwise this chapter is numerical free. This chapter is numerical free, so only in that portion numericals are there. Okay, so we'll meet in our next live session. Fine, but before leaving the class you must write your name here so that I can recognize that who are attending the class. Just write your name here, and then after that you can leave the class. Okay, thank you students, thank you. Yes, Karan Mitra, then Kesang, Karan Kesang, Subhama Roy, Shahil, Maitri, Amisha, Ratul, Pratham, Aryan Shah, Rohit Prasad, Priyansh Thakur, then Alex Nirmal, Sneha Chatterjee, Tapabrata Ghosh. Sneha, I have not got any answer from you today. What happened? Sneha, I have not got any answer from you when I was asking question. Nilesh De Vishwas, Subhendu, Sudipta, Suparna, Nitik, Tapabrata, okay, Alkamil, Jasraj, Shreya Kumai, okay, okay, Namrata, okay, fine. Thank you all of you. Thank you. Thank you.